Okay, here we go.
Ready? Hello, and welcome to this session of the North Bay Science Discovery Day. As you probably know, we're doing it virtually for the first time because of the COVID pandemic, and I hope you're having an interesting day today. Now, look at the rules on the left side of your screen. Please rename yourself to your first name only so that you can't be identified on screen. And keep your video off unless you are being okay with being recorded, and stay muted unless otherwise asked to unmute. And use the chat box for asking questions, please, or raise your hand to be called on. So this session is called 3D Design and Printing, and will be presented by three people from the Medtronic company, which happens to be a fine sponsor of our Science Discovery Day. So I'm now turning this over to Stella, Roland, and Paulina from Medtronic. Right away.
Awesome. Yeah. Thanks for the introduction, Stuart. I'm Roland Calloway. I am a process development engineer at Medtronic, and I work on designing the manufacturing process for heart valve delivery systems.
Hi, everyone, and my name is Paulina Nguyen. I'm an R&D engineer at Medtronic, and I'm working on a next generation ablation catheter for treatment of hypertension. So yeah, we'll get started presenting on 3D modeling and 3D printing today.
Yeah, let me share this real quick. Okay, is that showing for everybody?
It is, it looks great.
Excellent, thank you. Yeah, so just to begin, some of you may not be familiar with what 3D printing is. So what computer-aided design is. And computer-aided design is defined as the use of computers to aid in the creation, modification, or analysis or optimization of a design. CAD is really a fundamental tool for what we do in pretty much all throughout engineering, because it allows us to get a better understanding of what something is that we're designing without actually having to have a physical model in front of us.
Yeah, so you can see some really cool examples at the bottom. On the bottom left is a ship that someone has designed in SolidWorks. So something you see in real life. And then on the right is a pretty fancy car that's also designed using computer-aided design. And so at work, Roland and I use SolidWorks as our software of choice through the company, and we use it to design fixturing. We design our products through that, and it's a great way to just model something before having to do it in real life.
Absolutely, and right here we actually have a video kind of describing how SolidWorks works, and I'm going to try to share that here real quick. So let's see if this works. If you please let me know if you can't hear the audio.
Great design. These two simple words have driven individuals, companies, entire industries to develop the most amazing products ever seen yet, and drive SolidWorks to introduce solutions that simplify the process of designing and building products to accelerate your innovation. Great design always starts with a great idea. Today, you need the flexibility to capture ideas anywhere while expecting more from your tools to transform ideas into game-changing, innovative products. SolidWorks 2018's fully integrated design to manufacturing process makes this a reality. Smart manufacturing leverages the intelligence of the 3D model throughout the product development process. Great designs must ask the question, what if? A question that can't be answered without expensive physical prototyping. With SolidWorks integrated simulation tools, designs can be optimized and multiple failure modes can be considered long before the first prototype is built. Ultimately, a great design is validated, studied at every level, and analyzed throughout every step of the process. As the product moves through the design process, data is generated from everywhere and in many different forms. In order to facilitate your ability to safely share this data with the right people at the right time, a distributed data management system is paramount. One thing is certain about design in 2018. If a product is not connected to the web or another device, it will be. Employing a set of integrated design tools to develop connected products and systems helps you shorten design cycles, improve quality, and facilitate manufacturing. SOLIDWORKS 2018 provides you with an intuitive 3D development environment that helps maximize the productivity of your design and engineering resources. From design and analysis through data management and manufacturing, creating better, more cost-effective products faster than ever before. SOLIDWORKS 2018 is how great designs get built.
Yeah, so that's a great intro to kind of what SOLIDWORKS is and what you can do with it. So obviously, you can do quite a bit with it. Back into the, and here we go. Okay, so now we're going to be doing a little demo for you, actually in SOLIDWORKS. We actually have two prepared for you. So as we begin here, of course, we're not going to be building a full electrically outletted RV, but we'll be doing something a little bit more down to earth. So let me pull up SOLIDWORKS here real quick. So what we're going to be designing here today is a skateboard. And you know, you might think, okay, how do we start? Where do we start when we want to design something like that? So let's just begin by thinking of what individual components are to a skateboard. So you've got your board or the deck, which is just a long, flat piece of wood. Then you have a truck, which is the part that connects the wheels, and then the wheels themselves. And there's going to be two trucks, 4 wheels, and your deck. And in total, we actually only need to design 3 different components because we can make duplicates for all of these. So let's start out by designing the deck. So whenever you're starting out in SOLIDWORKS and you want to design something, you want to begin by figuring out a flat profile that you can just look straight at the thing, and you want to be able to expand from there. So for our skateboard, we're going to start from a side profile. So we want to be looking right down the edge of it. And this allows us to, take advantage of, we've got all these wings that are coming up at kind of weird angles. So we'll just start there. And what we're going to want to do is we basically take a look at that physical thing you had in front of you, and you dimension everything out. So, you figure out how deep how thick the wood is, how long it is, and what kind of the angle of these wings are. And then we're going to put that all into a simple 2D drawing. And now when we want to make it into something that's 3-dimensional, what you do is we go to our features bar up here and we hit extrude. And we're going to extrude it straight back. And this is what the result's going to look like that. So now this doesn't exactly look like a board right now. So what we're going to do is we're going to cut away. So just like we were able to make stuff, turn stuff from a 2D drawing into a 3D model, what we're going to do now is we're going to do a drawing that then converts into a cutaway. So we select the region that we want to keep, which will have the same profile if you're looking down on the board. And then we're going to make a larger thing that just encompasses everything else in our original model. And now we select, rather than select the extrude base, we're going to do extrude cut. And this is the result. Voila. Now that looks a lot closer to what our board should look like, but we still want to put a few more finishing touches on it. So let's add some holes to it. And the holes are pretty simple. We can make a little pattern using the construct features that are right here. So if you look at this, these dashed lines, they don't actually show up in your, when you go to extrude it, but they will show up and will help you to actually make sure everything's in place properly. So we're going to use this to ultimately interface with the holes on our truck, but that'll come down, that'll become apparent a little bit later. So we just, we'd use the same feature that we did last time. We do extrude cut, and voila, there are your holes. Now, lastly, it looks pretty good right now, but we want to make it look a little bit nicer. So what we're going to do is we want to make it round. We want to make the edges round, like you would have on a normal object. So what we're going to use is the fillet feature, and the fillet feature adds a radius to the side of of any kind of model. And it's a really good tool for, making things look nicer. And you can find that right up here at the top. So that's our deck designed. Now let's go to the wheels. So for a wheel, you might think, oh, we'd start with a circle, and you can do that, but we're going to do it a little bit differently. So we're actually going to start with this kind of rectangular shape almost with a little cutout on the side. But you'll notice that it's slightly offset from the origin. And this is, it doesn't have to be the origin, but we're just going to use that as a good reference point. And now what we're going to do, we created a little line right there. And rather than doing an extrude base, we can do a revolve base. And revolve base causes it to do this. Voila, right there. And we also have it filleted as well. So we have it nice and round looking. So yeah, it looks pretty close to what you would see on your wheel. And now lastly, we're going to take a look at the truck. So the truck itself, it's gonna be pretty complicated to model. I'm gonna leave out these little holes right here just because they're a little bit needlessly complex for what we want to look at right now. But we're still gonna be doing some of the more complex geometry here. So let's dive into it. So first of all, I want to start out with just once again straight down shot. I'm gonna look at it. I'm gonna leave off this top part right now while we're just walking through this. So we start out with this, and of course we once again going to expand that out. But now what I want to do is actually want to do a trapezoidal cut. And that's just going to be similar to what we were doing for cutting out the profile of the board. But instead, we're just going to go on the side here. And we're going to say, okay, that's about right there. That's about 0.75 inches. So that's going to be where it terminates. And now here we go. Okay, so we're getting closer. So now let's add that top bit right here so that we can attach the screw holes for it. So that's going to be, we just make a drawing that actually goes past our original model, and then we use that extrude feature to just build up. And there we go. And now we've got this looks roughly. But now what we want to start doing is we want to start rounding everything out. So the first thing that we're going to round out is we're going to start by selecting these three surfaces, and we're going to make everything on the bottom round, and that'll look like this. So that was just an advanced way of using the fillet feature. And now we're going to go and we're just going to round all the other edges separately. And now it looks a little bit more complicated, but it also looks a lot closer to what it would look like. And now we're just going to add, lastly, we're just going to do the same thing that we did last time, where we add just some holes in. So here we go. We're going to add some axle holes so that we can attach the wheels. And then we're going to add the attachment holes so we can attach the deck. So now we have all three of our components finished. So now we have to put them together into something called an assembly. So an assembly is a way to put together individual parts. So we're going to move here. And we're going to start by putting in our base component. So for your base component, you always want to try to use something that's going to be your big central component. So for this, we're going to use, of course, the deck, since that's going to be where most of our things are going to initially attach from. So you can see right here, it's just floating in space. So now what we want to do is we want to add a truck to it. So as we add the truck, we attach it by using a feature called a mate. And mates allow you to select two features from two different parts and cause them to align in a certain fashion. So for example, for this, in order to mate these two together, what I did was I selected the one of the holes here, and then I attached it to the corresponding hole, and there is one mate. And then I can do that again for one on the opposite side, and then with that one as well. So that's two mates. And then for the last one, what we're going to do is we just take the full top surface of the truck and we attach it to the bottom of the deck. And boom, now our entire, our truck is completely affixed to the deck. We're good to go. So now we're going to do the same thing for the wheel. But what we're going to do for the wheel is we're actually just going to do that. We're going to align the hole in the truck with the hole in the wheel. And then we're going to make that surface attach. We're only going to do two here though. And the advantage there is that it actually would allow us to spin this. I don't have a feature that would show that it's spinning. You actually can rotate this. you can kind of see it as the dashed lines in here are moved. So that's a way of doing it. So now we have 3 components in here, and we have all the components that we could need. I could go through and just add each of the next components individually, but we're going to use a neat little trick to make it a little bit faster and not have to go through all that mating process again. So first, we're going to start out by using a mirror. So we're going to mirror it across the truck. We're going to mirror one of the wheels across the truck, and that allows us to just immediately create another wheel to attach there. So then our next step is going to be to mirror all 3 of these parts across the halfway point of the deck, and the result will look like this. And there you go. That is a completed skateboard. Pretty simple model, but it looks pretty cool. So now I think Paulina is going to go ahead and give a demo that she came up with.
Yeah, thanks Roland for showing us an awesome demo of how to make a skateboard. So now I'm going to share my screen, and I'm sure this is pretty relatable to everyone playing with Legos when you were younger. So today I'm going to show the making of a Lego car in SolidWorks. So I'm going to shrink my screen a little bit. And I've already made all of the components, so I'm not going to walk through all of that. There's definitely a lot of components in this model, but I'm just kind of going to walk through how to do the mates and then how all the parts fit together. So I'm going to start off kind of just, showing how one part is made, and then we'll go through the rest. So here I have one of the bricks. So kind of similar to Roland, you do a 2D sketch, which here is just a square, and then you do a 3D extrusion. So you're extruding it into the 3rd plane so that it's in 3D. And if I just roll forward, you can see kind of the next feature that I've added. These signature little bumps that come out of the Lego to help you kind of click them all together. And then next, this is another feature called a shell. So it lets you hollow out the bottom of a piece, or not even just the bottom, but any piece really. So that's kind of, a signature to the Lego. And then next is that mating piece on the bottom. So pretty easy component to design. It took me about 5 minutes. So this is definitely something that you can all quickly play around with. And yeah, a quick design. So that's kind of the first piece, and I'll just go through all the other ones. So we start out with this first back brick piece. And I'm just going to show kind of the next piece, which is a floor brick. So you can kind of see like how it starts coming together, and kind of with how Roland showed all of those mates. So here, for example, I mated this edge with this edge so that they're parallel. And then I mated this edge with the edge on this one so that those are touching. So that's a quick kind of way to get components to mate in SolidWorks. And then I'm going to show this next piece. So we have this front brick. You've probably all seen this in your Lego kits as well. So yeah, mating kind of the same way, and very simple design. So let's keep going. So next is steering wheel. You can see it's kind of floating in space right here, and that's because I mated it to a different piece that I've hidden so far. But yeah, I mean, you can have pieces floating around in space if you don't mate them. So that's why it's a pretty important part of putting together an assembly, is making sure that all the parts you have fit together. So there we go. We have the steering wheel base, which fits onto this floor brick. So we're kind of starting to get there, right? Okay, now we'll start showing some of the wheels. So we have the wheel chassis, which are going to mount on the front and back, and those are where the wheels of the car are going to start fitting. So we have those two. You can kind of see how this is starting to come together. And then we have all of these parts. So I'm just gonna start showing them one by one. There we go. And those mount onto the chassis. And then we'll just kind of show the rest. But yeah, what I really wanted to highlight here was just how you start from individual components, and you can really get a whole big thing out of just creating mates in an assembly. So kind of like how they detailed in the 3D modeling video. I mean, you can get something as big as an RV designed in SolidWorks, something that complex. It really just takes care and, mating all of these components correctly. And if there are mates that conflict with each other, SolidWorks will tell you. So it's a really good guiding tool as you're designing. There's a lot of guidance within the software that will kind of show you what errors there are. And if you over dimension, if you add too many dimensions, it'll let you know that something's over defined. If you make mates that conflict, it'll let you know. So it's a great guiding tool and a great place to kind of start off with solid modeling. And I'll let Roland kind of share screen again and we'll go back to the presentation.
Excellent. Yeah, let me share this real quick. Okay, so now we're going to talk about 3D printing, and 3D printing is how you turn your CAD into reality. So as you can see on the screen right here, let me actually. So as you can see on the screen right here, on the left, you've got a 3D SolidWorks model, and on the right, you actually have something in reality. So the thing on this this device right here is actually a fixture that is used to hold a object in place while you shine UV light on it to cure glue that would be inside of it. And that's where that little wire that you can see on the side there is heading to. It's actually a UV light. So this is a kind of a demonstration of how this tool can actually be used for something practical, where you can use it in a work scenario. And now we're going to do a little demo. We're going to have a video that shows a demo of how 3D printing works. Pull that up here real quick. And here we go. Awesome, yeah. So how that worked was, if you take a quick look through that video, it starts by just depositing plastic material on a surface, and then as the surface moves down, the head on the 3D printer just starts depositing material on top of it, and that material then solidifies and creates your object. And that's one of the strategies for doing a 3D printer. There are a couple other 3D printer models that will kind of they'll do a little bit of a different strategy, but for the most part, this is how most 3D printers will work. And let me go back to the presentation. So if you're interested in getting involved in 3D modeling or 3D printing, a place where you can look for CAD design software would be these kind of three options right here. And one option that you have is Fusion 360. It's a free solid modeling and design software that's available through Autodesk. And they're pretty simple to use. They've got a lot of good tutorials that you can go through. And then you, of course, have SolidWorks as well, which is what we use in our work. And there's also AutoCAD, which is kind of a more advanced version of Fusion 360.
Yeah, and if you're interested in getting involved with 3D printing or trying it out, the Sonoma County Public Library offers free 3D printing, so that would be a great resource to check out. I'm not sure with COVID restrictions how they're operating, but definitely a great resource otherwise. And you can also build your own 3D printers. So there are a lot of resources online showing how to build your own at home if you have that extra time and want to give it a try. There's also a lot of 3D printers now that are out on the market for a pretty affordable price. So it's definitely something pretty cool to have at home. You can 3D print phone cases, anything, you know, kind of small that you need lying around. You can see from that video that the material gets extruded on a plate. And so that plate has only a given surface area that you can print on. So that kind of limits the volume that you can print with. But yeah, it's a great resource and helps you kind of get what you need at home. Yeah, so with that, we'll kind of open up the Q&A. I know there were some questions that came through on the chat, so I can kind of start reading through them. Someone asked what the app was called. So what the software that Roland and I both showed is called SolidWorks. And so you need a license to use it. We have a license that's provided through Medtronic, but if you're taking maybe like an intro engineering class at school, it could be offered there. Or if you, you know, are going into engineering for college or anything, it's often provided by the school. But some of those resources like Fusion 360, like Roland mentioned, are free. So definitely check those out.
And I see there's a question here. Would a 3D printer be able to actually print a scale skateboard like that? It depends on the size of your skateboard and the size of your 3D printer. It's really, you know, sky's the limit. One thing that you would have to look into for that though is your actual material. Typically 3D printers, they can only print in plastic. There are some really advanced ones that can actually do metal 3D printing. Those are a lot harder to come by. But for the most part, it'd be a little tricky if you wanted to like actually have one that would be strong enough for you to ride on it. But maybe, I don't know, if you could want to like print the penny board, one of those kind of size things, I think that would probably work.